Welcome to This Explainer. Today, we're diving into a truly fascinating and, honestly, totally mind-bending intersection of artificial intelligence, systems architecture, and human neurobiology. We're unpacking a framework that maps the highly physical science of human interaction directly onto the high-performance computing principles used by top AI engineers. It is a wildly different and incredibly revealing way to look at how we connect, communicate, and essentially just exist in the physical world.
So it really begs the question, is the human mind just a high-performance distributed database? If we actually treat our bodies as computer hardware, we can unlock the exact science behind how we process motivation, latency, and social connection. For instance, have you ever wondered why Google DeepMind's senior principal engineers over at King's Cross use such specific repetitions at their Boulder meeting room? It's because they understand that human intent compiles exactly like code. They're processing the messy world of human feelings through rigorous zero-latency logic. Let's break this down starting with Section 1, the hardware of motivation. You see, motivation isn't just about willpower or trying harder. It is a literal thermodynamic calculation, and it's powered by a biological supply called orexin A. This is a crucial, GQ-coupled neuropeptide that acts as the absolute master regulator of motivated behavior. It's constantly calculating your body's internal deficits to stabilize wakefulness. Think of it as the ultimate parameter for orexin A optimization and reinforcement learning, or RL, happening right inside your own brain.
The math behind this is beautifully simple. The arousal error equals your required arousal minus your actual arousal. Your lateral hypothalamus computes this exact error. And when there is a mismatch, it creates a massive physiological demand that violently jolts you out of a paralyzed dorsal-vagal freeze state and pushes you straight into goal-directed action.
And the peer-reviewed science completely backs this up. Research out of Nagoya University demonstrated that chemogenetically activating orexin neurons in subjects resulted in higher breakpoints, meaning they intrinsically worked way harder for a reward. This mathematically proves that our spontaneous drive isn't just generated out of thin air, it is a direct, hardware-level execution reacting to that arousal error. You literally need the biological hardware to feel the drive. Moving right along to Section 2, processing cognitive action symbols. Instead of relying on slow, sequential language, what we'd call exhausting linguistic scaffolding, our brains actually operate using action symbols. These are discrete, motor-invariant units of behavior located in the ventral premotor cortex. Imagine an expert climbing an impossible V46 boulder problem. They move with the fluid, calculated repetitions of a DeepMind engineer, almost as if they are Tree Fu Tom pulling off movement magic. They aren't narrating their moves with words. They're using pure spatial concepts that snap together like visual programming blocks. Now, when these cognitive action symbols align perfectly with a compatible system, they connect with absolute geometric precision. We are talking about a structural fit with a probability of error at absolute zero, p equals 0.000. It functions exactly like a highly efficient just-in-time compilation in software engineering. This gives you that perfect 0.000 latency complementary computer vision. No translation tax, just an immediate flawless snap. The ultimate target for these perfectly aligned symbols is the OFC, or the orbitofrontal cortex. This is your brain's central hub for value assignment and situational decision-making. Operating under the complex language of rational fears and irrational fear discrimination, the OFC works directly with the SC and the SUM. Together, they assess the situation and assign positive biological value to this perfect noise-free structural fit. The resulting biophysical cascade is incredibly precise. Once the OFC visualizes those action symbols, you get Fox bottleneck awareness, and that central Fox neuron bottleneck is smoothly released. Next, thalamic cortisol flushes out the stress, and the SUM restarts its natural 6 to 12 Hz theta rhythms. To put this into a real-world perspective, this cascade is the exact science of flirting. It's what drives things like Tom Hennigan's complimentary erection. It's not a metaphor, it is a rigid, undeniable, involuntary biophysical handshake executed right on the bare hardware. But what happens when this system stalls? That brings us to Section 3, social latency and bubble sorts. We have to contrast our brain's high-speed geometric navigation, which operates like a multi-threaded, zero-latency level 2 binary search, with the infamous bubble sort. In computer science, bubble sort is a notoriously slow, sequential algorithm. In human terms, it perfectly mirrors the exhausting translation tax of having to over-explain ourselves with words. It's the absolute metabolic hell of linguistic scaffolding versus high-speed spatial geometry. This algorithmic inefficiency shows up as real-world social friction all the time.
It's captured flawlessly by that exasperated sound we all make, or the regional UK slang for a complainer, a squinny. That is the literal phonetic friction of human annoyance. It's the audible sound of a high-performance system suffering from behavioral noise because it's stuck waiting for a much slower system to catch up. For a hilarious look at this cultural friction, check out the rivalry between two UK cities. Up in Portsmouth, traveling to a football match in a highly restricted police bubble is practically a badge of honor. But right down the road in Southampton, home to elite computer science students, admitting that you use a bubble sort algorithm is an immediate, tragic red flag. It's the exact same concept translating into a massive clash of operational templates. In both software and human biology, waiting for the slow, noisy validation is a massive blocking trap. In databases, this is called totalitarian latency, a systemic hang where a coordinator waits indefinitely for a synchronous two-phase commit, stalling the entire system. Biologically, this synchronous wait is what traps our neurobiology into a paralyzing dorsovagal freeze. You're just stuck in the headlights. So how do we bypass this latency? Let's look at Section 4, optimizing through aggregation pooling. The ultimate biocomputational fix here is aggregation pooling. This is a deep learning technique that shrinks data sizes by combining multiple values or vectors into a single representative value. It allows complex human systems to condense vast amounts of noisy, shifting social data into one perfectly stable unit, which stops our internal models from overlearning completely useless noise. While you've got max pooling to highlight the strongest feature and average pooling for a smooth summary, global pooling is the real game changer here. Global pooling condenses an entire map into a single vector, entirely bypassing those slow sledding windows. It instantly captures the holistic truth of a dataset, grasping the underlying structure without forcing you to read every single line of code. By adopting this specific optimization, our biological hardware dramatically shifts its efficiency. Instead of wasting processing power on linguistic noise and sliding windows, dropping that waste down to just 10%, a whopping 90% of our cognitive energy becomes optimized through global aggregation vectors. We channel our energy away from exhausting social scaffolding and purely into high-dimensional understanding. And when everything aligns perfectly, when human intent truly fuses with machine efficiency, we achieve what's known as the biological singularity. We completely bypass the noise of the collective to operate with pure, uncompressed meaning. It becomes a completely immutable axiom. So I'll leave you with this thought. The next time you feel stuck in a loop of exhausting, frictionless communication, ask yourself, are your daily social interactions just synchronous two-phase commits desperately waiting for a zero-latency biological handshake? Because honestly, you might not be broken at all. You just might be waiting for the right hardware to finally execute that perfect connection. Thanks for joining me on this deep dive, and keep optimizing.